So one thing I want to show you in the build section is overlapping. We talked about overlapping a lot. Now, we all have seen what's the way to solve overlapping IPs in a traditional layer 3 sense, right? Let's say two IPs need to talk to each other that are overlapping. All you have to do is put a router here, do source NAT, destination NAT, and somehow that traffic will start working. I could have shown, we actually absolutely can do that. I could have shown you that demo, but we wanted to show you something that's way more cooler. And we think that the overlapping IP scenario in this today's world can actually be solved using this whole service networking concept that we've been talking about, right? So especially think about the customer that I was talking about. Hey, I have the partners that need to access services that are running in my own setup. Now the thing is that partner, I can't control what IPs the partner is using, the application or the service, and I already have my services built out. How do I actually go ahead and solve this problem? So the way we are solving this is, and of course we are just enabling it, cloud providers are in a way have solved it and we are just extending it, is you bring these constructs like private link into the picture. So what we are saying is, as long as you connect your source or your network to Prosimo Fabric using a construct like private link in AWS, Azure, or in GCP, we will sit in the middle as a reverse proxy, and the source here can talk to a destination. The source and destination can absolutely be on the same IP. Forget about overlapping VPC CIDRs. They can actually be on the same exact IPs. And I'm going to show it to you here. So I onboarded this as a private link source. Prosimo took care of everything that is required for this private link to work. We need to create a load balancer, endpoint services. All of that is taken care of. But now what we are saying is that, hey, just onboard or attach this network to Prosimo using private link, which is great. So we will just click on next and hit launch, and it will go and do a bunch of things. It will also go in your source side, create a Route 53 private hosted zone, make sure that all of your DNS part is also taken care of. But in the end, and then you're just talking to a service that has the exact overlapping IP. So I onboarded a web application that actually is sitting on the same 1078.0.12 that my source is sitting here on, right? This is my source and my destination is the same thing. It's just an Ubuntu Apache server running in that particular. But just to show you, exact same IPs are able to talk to each other without having to configure and source NAT and destination NAT rules. Now, we are able to solve it at service layer. If at all, we also have customers who feel more comfortable solving it at the network layer. We actually can do the traditional source NAT, destination NAT part as well. But just wanted to show you how overlapping IPs can talk to each other through Prosimo.
That goes back to your point of why should we use a logical identifier versus physical identifier? Here, the physical identity is exactly the same IP address, but we're able to make them talk to each other using our logical identities.
Yeah, not everything needs to be solved at the, at the IP layer. Right?
What?
Just tell that to everybody trying to do IPv6 right now.
Okay. And yeah, sorry. Just one more thing here is, it's good that you're making the source and destination talking to each other. I don't care whether it's source, whether it's a network, application, service. This is all good. But I also want to bring in the firewalls into the mix. In the data center, all of my traffic used to go through my firewall rules. I can. So this customer in specific was using Azure native firewall as a service. But we also have customers who are using Palo Altos, checkpoints, or FortiGates, or anything else, right? What we can do is we can bring in and we can integrate with those firewall services hosted in customers' cloud environments as well. So we go ahead, discover in which account your firewalls are running. Are they front-ended by a load balancer and whatnot? You onboard this. We will take care of whatever is required to connect this Prosimo Fabric to this firewall service. That will be automated. And then you create a policy which says, I want to create a service insertion policy that actually, whenever this source is talking to this particular target, please funnel it through my firewall, and because that's where our security policies are living. So any source, any destination, no matter where the source or destination is, it could be data center, it could be cloud, other regions, we can funnel it through the firewalls as well. So
it's a little different in terms of it's not like we are sending each and every packet and bytes to the firewall. It's a filtered traffic from a source that is going to the firewall. How does it help our customers? They can accordingly plan like how many kind of resources they need in terms of compute for a firewall. They can properly plan this, like, I mean, if there's a scope that they have to kind of span on the firewalls. So if we start sending, let's say, a staging traffic and the production traffic, everything to a firewall, eventually you have to kind of start kind of adding more kind of in the firewall form. So this will help them kind of have their traffic kind of filtered. What is absolutely requiring a deeper inspection of the traffic, only that traffic will be steered towards the firewall, which is kind of a unique way of kind of solving this issue itself for the service insertion.
So like economically also it has a lot of impact, right? Because earlier I did not have a good story for microsegmentation inside my VPC. What was my strategy? I'll send everything to this firewall. I'll implement that was my policy enforcement point, right? Now you actually are getting this stuff off the shelf. You're getting adaptive service insertion, which means from a VPC wholesale does not need to go to a firewall IDS IPS instance. You could actually fine tune that, which means this firewall, the shared service, does not become a choke point in terms of either bandwidth or capacity or any of those pieces anymore, right? So you have now the ability to actually fine tune the flows that are actually going through these shared services.